This is Module 8, Section 3.3. In this section, we're going to look at intercepts in general, and specifically x-intercepts and y-intercepts for our linear graphs. The definition of an intercept is the point or points where the graph of an equation crosses an axis. Now, if you're looking at a rectangular or a Cartesian coordinate system, there are two types of axes, x-axis and y-axis. So there's two types of intercepts, x-intercepts and y-intercepts. An x-intercept is a point or points where your graph crosses the x-axis. So let me give you an example of that. Let's say that you had a curve on this particular graph that maybe looked something like this. All right, now by definition, we're interested in where that graph crosses the x-axis. So you would agree with me that as I drew this curve, this graph crosses the x-axis in three different places. Okay? In terms of ordered pairs here, we move 1, 2, 3, 4, 5 to the left, so that would be -5. And in terms of y-axis movement, we move neither up nor down from that axis, and so it will be -5, 0. This point right here, of course, is the origin, so that's 0, 0. And here we've got an x-intercept of 6 to the right and 0 up or down. So these are examples of x-intercept points. Now let's say over here, y-intercept, the definition is the point or points where a graph crosses the y-axis. So let's say, for discussion's sake, over here, you maybe had a curve that looked like this. That's a very poorly drawn curve. But let's say that it crossed right here at this +8 and right here at that +2. Okay? All right, so the point, in this case, the points where this curve crosses the y-axis would be from the origin 0 left or right and 8 up. Okay? So your x, y point would be 0 left or right and 8 up. This point right here would be 0 left or right and 2 up. All right. Now, if we refer to the previous graphs, and I'll go back to it in a minute, the next question is, what do all x-intercepts have in common? So if we go back, and our curve is gone, so that's all right, we'll look at x-intercepts again. Let's say I gave you this curve now. You had one that maybe looked like this. Okay, and we looked at the x-intercepts. This point right here is, let's see, -4 to the left and 0 up or down. This point right here is 3 to the right and 0 up or down. And this point right here is 10 to the right and 0 up or down. If the question is, what do all x-intercepts have in common? The answer is the x-intercepts have in common that y is equal to 0 in every single point. And the question is that true? And the answer is yes. In order to be on the x-axis, you can neither have moved up or down from that point. So y, which is up-down movement, has to be 0. So that's something that x-intercepts have in common, is that y must be 0. So let's think about y-intercepts, and we'll see if I can draw it a little better than we did in the previous example. Let's say that you had a curve maybe that was coming around like this. Okay? And I was interested in where that curve crossed the y-axis. You agree with me that it crosses here, and here, and here. All right? Now the ordered pairs there, remember you have to do the x movement first. From 0, 0, I move 0 left or right, but I move 5 up. This point right here, 0 left or right, and 1 up. This point right here from the origin, 0 left or right, and 4 down, so 0, negative 4. Again, the question is, what do those three y-intercepts have in common? And the answer is, in this case, x is always 0. And is that always true? And the answer is yes. In order to have a point on the y-axis, you can't have moved right or left off of the axis, which means x has to be 0 in order to not move left or right, because that's what x movement does. And so, if we summarize that on this slide, what do all x-intercepts have in common? They occur where y is equal to 0, always. And what do y-intercepts have in common? They occur where x is equal to 0. Therefore, to determine an x-intercept, if you're given an equation and not a graph, all you have to do is set y equal to 0 and then solve for x. It's like getting an ordered pair, but they're telling you what to let y be. Okay? And if you're trying to find the y-intercept, instead of letting y be 0, you'll let x be 0 and solve for y. Also note that if you find the x and y intercept for the same equation, you now have 2 points that you can plot and draw your line through to graph your equation. A third general point can be found additionally to check the accuracy of your intercepts. But that point is made to help you. If you're asked to graph an equation and find the intercepts first, then you have 2 points already. You can use those 2 points to graph your equation, get a third to check it, and you're that much farther ahead. All right, so for this problem, that's what we're going to do. We're going to use that equation. We're going to find the intercepts for the equation, which usually will give you 2 points, and then graph it. All right, so we need to keep track of our points, as always. So in order to find the x-intercept, I'm going to let y be 0. Okay? So to find x-intercepts, let y be 0 and solve for x. So we'll do that. We're going to let y be 0 in our equation. So we've got negative x plus 2 times 0, because we're letting y be 0, is equal to 4. 2 times 0 is 0, and negative x plus 0 is just negative x is equal to 4. Now we don't want negative x, we want positive x. So recognize a negative x is the same as negative 1x. So we're going to divide both sides by negative 1, and x is equal to 4 divided by negative 1, which is negative 4. So that is our x-intercept point, negative 4, 0. Our y-intercept, we said, occurs where x is 0, always. Y-intercepts occur where x is equal to 0. So to find our y-intercept, we're going to let x be 0 and solve for y. Okay, so let's do that. So we've got negative 0 plus 2y is equal to 4. Negative 0 and positive 0 is just 0. So we've got 2y is equal to 4. And if we divide both sides by 2, y is equal to 2. So when x is 0, y is 2. That's our y-intercept. Now we can graph our line with just those 2 points, but let's get a third point just to check. So I'm going to choose to let y be, 4. Okay? So I'm going to let y be 4 just because I picked that. So I've got negative x plus 2 times 4 equals 4. Or negative x plus 8 equals 4. Subtract 8 from both sides. Negative x is equal to 4 minus 8, which is negative 4. And remember, that's a negative 1. We have to divide that negative 1 out. and x is equal to negative 4 divided by negative 1, which is a positive 4. So let's plot those points, make sure they all lie in a straight line. We've got negative 4, 0 is 4 to the left and 0 up or down. We've got 0, 2, which is 0 left or right, and 2 up. And we've got 4, 4, which is 4 to the right, 1, 2, 3, 4, and 4 up, 1, 2, 3, 4. Those all should lie in a straight line, and it looks like they do. So we'll draw our line through there. If you're asked to label intercepts, this, of course, is your x-intercept. It's the point where your graph crosses the x-axis, and this is your y-intercept. It's the point where your graph crosses the y-axis. All right, let's do the same thing for this equation. Y equals negative 1/2 x plus 3. Y equals negative 1/2 times x plus 3. Okay, we need ordered pairs. In order to find the x-intercept, we're going to let y be 0. In order to find the y-intercept, we're going to let x be 0. And then we would want to find a third point. And so for my third point, I'm going to choose to let x be 2. All right, so x-intercept, let y be 0. So we get, for the x-intercept, we're going to take 0 equals negative 1/2 x plus 3. Let's clear fractions by multiplying everything by 2. So we've got 2 times 0 equals 2 times negative 1/2 x plus 2 times 3. Remember that 2 will cross cancel here. So now we've got 2 times 0 is 0 is equal to negative 1x plus 6. Trying to solve for x. So I'm just going to add 1x to both sides to move it to the other side, because I recognize that 0 plus 1x is just 1x, and 1x is just x. So by moving that over, I've got it solved. When y is equal to 0, x is equal to 6, and that's my x-intercept. All right? Let's find our y-intercept. To find our y-intercept, we're going to let x be 0. So we get y equals negative 1/2 times 0 plus 3. Anything times 0 is 0, so we get y equals a positive 3. For our y-intercept, or the ordered pair, would be 0, 3. All right, now we've got a third checkpoint here, so we're going to let x be 2. So we've got y equals negative 1/2 times 2, or 2 over 1, since that's being multiplied to a fraction, plus 3. Notice your 2's cross cancel out, leaving you with a bunch of 1's. So you've got y equals negative 1 plus 3, and negative 1 plus 3 is 2. Okay, so plotting those points, we've got 6 to the right and 0 up or down. So 1, 2, 3, 4, 5, 6 to the right and 0 up or down. That's our x-intercept. We've got 0 left or right and 3 up. So 0 left or right and 1, 2, 3 up. That's our y-intercept, the point where the graph crosses the y-axis. And we've got 2, 2. So we've got 2 to the right and 2 up. That's just our third checkpoint. They do look like they lie in a nice straight line. And we've got our equation y equals negative 1/2 x plus 3 labeled. All right, now let's look at this problem. Y equals 3x. When you're looking for intercepts, remember for your x-intercept, you're going to let y be 0. And for your y-intercept, you're you're going to let x be 0. But this is one of those equations that goes through the origin, and if you're not sure about that, try to do this first problem here. If you let y be equal to 0 to try to find your x-intercept, you get 0 equals 3 times x. And if you try to solve for x by dividing by 3, you find that x is equal to 0 divided by anything except 0 is 0. So in this case, this equation goes through 0, 0, which is both the x and the y-intercept. So we don't need to do this because this point right here takes care of crossing both the x and y axis at the origin. So this is both our x-intercept, because we're touching the x-axis, and it's our y-intercept, because that's where we're touching the y-axis also. So 0, 0 is both our x and our y-intercept, but we're trying to sketch the graph, so we need some other points. So since this is solved for y, if I pick some x values, I don't have to do much work. So I'm going to let x be 1, and I'm going to let x be 2. If x is 1, I get y equals 3 times 1, or y equals 3. So when x is 1, y is 3. If I let x be 2, I get y equals 3 times 2, or y equals 6. So when x is 2, y is 6. So if I plot those points, I've got 1, 3 is 1 to the right and 3 up. So 1 to the right and 3 up. And I've got 2 to the right and 6 up. So 2 to the right and 1, 2, 3, 4, 5, 6 up. And again, it does look like those lie in a straight line, but goes through the origin 0, 0. Y equals 3x. Okay, now what about special case lines? Okay, notice that this is one of those special case lines where we are missing the x variable. So our technique for graphing these was to look at the equation at face value. This says y is equal to 5, and y has to be equal to 5 in order for that to be true. You can't let y be anything else. X, on the other hand, can be anything you want it to be. Now, if we graph that, let's go ahead and look at that in terms of intercepts. We've got 0 left or right and 5 up. 1, 2, 3, 4, 5. 0, 5. We've got 1 to the right and 5 up. We've got 2 to the right and 5 up. This is one of those horizontal line cases at y equals 5. Notice that there is a y-intercept. Okay? Your y-intercept is where x is equal to 0, just like we talked about before, but there is no x-intercept. No x-intercept. Because it's a horizontal line, it's parallel to the x-axis, and it's never going to cross that. Okay? And mathematically, that makes sense because in order to have an x-intercept, you would have to be able to let y be equal to 0. And if you put 0 into this equation, it makes no sense. That's not true. You can't do it. Okay? And that tells you simply that there's no x-intercept for that particular line. So then on the flip side of that, if you're looking at an equation that you're missing the y value, like x equals -7. If you graph that, okay, x there has to be -7. Y can be anything you want, but x has to be -7. And what that means in terms of intercepts is you can't let x be 0. Okay? And if you can't let x be 0, then what that means is there's no y-intercept because x has to be 0 for the y-intercept. So let's graph those points and see if that's true. If we graph -7, 0, that's 7 to the left and 0 up or down. If we graph -7, 1, that's 7 to the left and 1 up. And if we graph -7, 2, that's 7 to the left and 2 up. All right. Draw that in. We've got that vertical line, which we expect when we're missing a y variable. Notice that, as we predicted, there is an x-intercept. Okay? That x-intercept occurs where y is equal to 0, but there is no y-intercept. That curve is never going to cross that y-axis because it's parallel to the y-axis. And that's what we predicted as well. So this is the end of Module 8, Section 3.3. This is also the last video for Module 8. So you should complete the homework for Section 3.3 in MyMathLab. Then when you have successfully completed the homework, review all the material for Module 8 and complete the Module 8 exam, also found in MyMathLab. And after successfully completing the Module 8 exam, you may proceed to the Module 9 videos.